Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next problem. Problem having been chosen from the same book, that is Modern Physics by Kenneth S. Crane. Okay. As usual, we first come to its statement. Statement of the problem is compare the frequency of revolution of an electron with the frequency of the photons emitted in transitions from n to n minus 1 for part A n equal to 10, n equal to part B n equal to 100, part C n equal to 1000 and part D n equal to 10,000. Dear students, here nature of problem is that all of our effort will be, or most of our effort will be only to the extent of part A. Okay, and on the basis of part A we will come to solution of part B, C and D quite quickly. Okay. Dear students, this problem is a little complicated, or perhaps it may be said that it is not a soft task, it is a slightly hard. Okay, anyhow we come to its solution, but before solution, as usual, we first come to helping tools. Okay, so our first helping tool is frequency of revolution, an expression which has been taken or chosen from the same book, that is Modern Physics by Kenneth S. Crane. Okay. This snapshot has been selected from the book which we are following, Modern Physics by Kenneth S. Crane, frequency of revolution. Fn is equal to me raised to the power 4 over 32 pi raised to the power 3 epsilon naught raised to power 2 h cut or h bar or h reduced raised to power 3 and n raised to power 3. Okay. Dear students, for this problem we will introduce about 9 or 10 helping tools, and those some of those helping tools have already been applied, used. Okay. Dear students, here to the extent of tool number 1, it can be said that first and direct method of solving this expression is just putting all values of these physical constants and then to solve that. Okay, but in that case definitely we will solve enough complications. Okay, because dear students, actually the main thing is that when we use value of some physical constant, it does not mean that we are just using its value. Okay, value is just a number, but that number is expressed in some units, and usually such units are derived units, in which basic units are several, more than one of different nature, and when so many multiplying factors are involved, then many different types of units are involved, and their simplification takes a long time. Okay, so in this problem we will also mention all these physical constants separately, but it is not necessary that all such physical constants will be used or applied in the solution of this problem. Okay, we may bypass these physical constants and use a few combined combined constants which serve as a facilitating measure for us. Okay, for example, dear students, the most facilitating step in this problem is the value of e raised to power 2 divided by 4 pi epsilon naught. Okay, and value of that expression is equal to 1.44 1.440 electron volt into nanometer, or million electron volt into femtometer. Okay, so our strategy will be that we will first find such combined constants from this mixture of large number of physical constants. Okay, then we will separate the other multiplying constants. Okay, so this will be our methodology almost. Okay, now tool number 2. This tool number 2 has also been chosen from the same book, that is Modern Physics by Kenneth S. Crane. Okay, this is radiation frequency, F equal to me raised to the power 4 divided by 64 pi raised to the power 3 epsilon naught square h cut cube into 1 over n minus 1 square minus 1 over n square, and this expression alternatively becomes equal to me4 over 64 pi cube e epsilon naught square h cut cube n square into n minus 1 square. Okay, we will use these two expressions as our basic expressions for the purpose of reaching our desired solution. Okay, now we move to tool number 3. Dear students, in this tool, this value, that is e square over 4 pi epsilon naught equal to 1.440 electron volt nanometer or million electron volt femtometer, this factor is very important, and we will try to convert all both these two expressions in one way or the other in this form. Okay, that is to say, first we will separate this type of expression from this type of combination of constants, and then remaining constants will be separately multiplied. Okay, so in addition to this, speed of light c 2.9 power 8 meter per second, this may also be used. Okay, e equal to 1.60 to 10 to the power minus 19 coulomb, this may also be used. Okay, but it is our discretion whether we use these values or we bypass these values by some alternate method. Okay, moreover, value of Planck's constant which is given in second format, that is 4.136 into 10 raised to the power minus 15 electron volt second, this may also be used. Okay. Moreover, electron mass 0.511 million electron volt over c square. This may also be used. Moreover, combined value of h cut c. Okay, this is the combined value of hc, but this is the combined value of h cut c or h bar c or h reduced c. Okay, so this value may also be used. Okay. Yes, it is enough about tool number 3. Now we move to tool number 4. This tool has also been used several times in our previous problems. Okay, from this tool, this value, that is 0.511 million electron volt in place of mc square, or in place of this we may write it as 511000 electron volt. Okay, this value will also be used from this table. This value 0.511 million electron volt or 511000 electron volt will be used. Okay, in tool number 5, dear students, this is called Coulomb constant or electrostatic constant, and this is equal to this. Okay, we may also use this, but it is much better if in place of this we also include E square in this, that is E square over E square into K, because this is the value of K, we multiply it with E square, so that E square over 4 pi epsilon naught, its value is 1.44 into 1.440 electron volt nanometer or a million electron volt femtometer. Okay. From here, in this expression, the value of epsilon naught, that is permittivity constant, has its value in this form. Okay, we may separately use this value, but no need for separate use of this value. Okay, because this value is contained in this combined expression, and this combined expression is contained in the combined expression E square over 4 pi epsilon naught. Okay, okay. So we will prefer E square over 4 pi epsilon naught. However, it is better to mention all values separately. Okay, just in order to have basic understanding. Okay. Moreover, tool number 6, this tool has also been applied several times in our previous problems. Okay, for electron, E or E minus charge minus E, for proton charge plus E, symbol P, for neutron symbol N, and charge 0. Okay, now we move to tool number 7. In this tool, elementary charge has been defined. Okay, elementary charge has been defined. We will not go in detail. In tool number 8, Coulomb's law has been defined or explained, in which value of epsilon naught is given separately. Moreover, value of electrostatic constant or Coulomb constant, that is K, which is equal to 1 over 4 pi epsilon naught, is also given. Okay. Tool number 9, 1 F is equal to 1 farad is equal to 1 coulomb over volt is equal to 1 coulomb over volt, when farad is equal to 1 coulomb square over Newton meter is equal to 1 coulomb square over joule. This conversion factor, this is a conversion factor. Actually, it may be used in the next helping tool, which is just a counter check. Because we have given much more importance to this combined constant, that is E square over 4 pi epsilon naught, and we know that its value is equal to 1.440 electron volt nanometer or million electron volt femtometer. So here by using all these constants separately, we have tried to recheck or counter check that it is quite okay that its value is equal to 1.4427504 electron volt nanometer. Okay, so this was just an additional thing, never necessary for the solution of this problem. Now we come to its solution in a proper manner, in a formal manner. Okay, first we come towards the part A of this problem. Okay, so solution of part A, we say we know that frequency of revolution is given by Fn is equal to me4 over 32 pi cube epsilon naught square h cut or h bar or h reduced cube n cube, equation number 1. What is this? This is just tool number 1. We have just reproduced that tool there. Okay, next we say that rewriting equation number 1 as why need for rewriting this equation, dear students? Actually the reason for rewriting this equation in this form is that we have emphasized enough on this fact that this combined constant, that is this combination of physical constants is of much importance for us, is a matter of facility for us. Okay, so we must avail this facility in order to solve our problem in a short time. Okay, so from here we have separated e square over 4 pi epsilon naught. Then once again here we can also write it as this whole square, or whether we write it twice as a multiplication form, or we write it as a square of this quantity, it is one and the same thing. Okay, so when we have write this thing, it means from this expression e raised to the power 4 has been separated. Moreover, from 32 16 has been separated, because 4 into 4 is equal to 16 and only 2 has been left. Okay, from pi cube, pi square has been separated, because this is pi and this is pi, and only one pi has been left. Moreover, epsilon naught square has been separated, because it is also epsilon naught and it is also epsilon naught. Okay, now next what we have done, we have just made an arrangement. What arrangement? Arrangement is that we have multiplied as well as divided by c square. No difference. Okay, the benefit of this will be that in the numerator we will become mc square, and in place of this mc square we may use the value 0.511 million electron volt or 511,000 electron volt. Okay, in this place, and below c square in combination with h cut will become this whole square, and the value of this combined, that is multiplication of these two constants, is also given in table as a single value, and multiplication of these two is also given in the table as a single value. Okay, so we are taking these steps just in order to facilitate our problem. Otherwise, if we straightforward put all values of maximum physical constants and then simplify their units and then convert them in one to other physical quantity, it will be a little laborious or lengthy task. Okay, so we are here adopting this technique in order to bring our problem in a systematic approach, systematic method. Okay, now here what we have done, we have multiplied and divided by c square, so we will not consider this c square. Now what has been included from this expression, m has also been separated, and h cut square, here is, this is h cut cube, so it means from this h cut cube, h cut square has been separated, and now only one h cut or h bar or h reduced has been left. Okay, so up to this I have explained enough, and I think it should be clear. And now we write that part of this expression which has not been included in these three separate measuring factors. Okay, so what is left? In the numerator nothing is left, both quantities have been included, so in the numerator 1 is left, while in the denominator 2 pi is left, because 30 out of 32 16 has been included, and 16 into 2 equal to 32, so this 2 is that. Okay, moreover pi into pi square has been used from this pi cube, and simply 1 pi was remaining, which is written in this form. Okay, moreover one h cut or h bar or h reduced was left, which is written in this form. Okay, moreover 1 over n square n cube is also remaining, which has not been included in these three, so it has also been written in this form. Okay, I think I have tried my best to make the things clear, and I hope my style will work. Okay, so in the next step, dear students, we will use 10 in place of n. Okay, when we will use 10 in place of n, then first we use the value of this expression, which is for 1.40440 electron volt nanometer, because this into this is actually square of this quantity. Both these combination of physical constants is same, so we can say that it is a square of this. So value of this is this, and it will be written in square form. Okay, next in place of mc square we have written its value. Okay, 511,000 electron volt. In place of this we can also write 0.511 million electron volt, but it is our discussion. Okay, we have to use one of these two values, either 511,000 electron volt or 0.511 million electron volt. Okay, moreover h cut c or h bar c or h reduced c has value 197 electron volt nanometer, and this is also because in square, so it is written in square form. Moreover, multiplied by 1 over 2 pi, yes, 1 over 2 pi h cut into n cube. So in the numerator there is 1. Oh yes, I have understood. Because we have used n equal to 10, so n cube will become 1000. Because 10 raised to the power 3 is equal to 1000. So this 1000 is when we use 10 in place of n. So n cube has been changed into 1000. Moreover, then next, what next? What next is what next is that oh yes, okay, one more thing has become clear. Dear students, this is 2 pi h cut or h bar or h reduced. We know that h cut or h bar or h reduced is equal to simply h, that is Planck's constant, divided by 2 pi. So this 2 pi will be cancelled with this 2 pi, and hence 2 pi h cut will become equal to simply h. Okay, that is why here value of Planck's constant has been used. Okay, so I think nothing is left ambiguous. Everything has been made as clean as crystal. Okay, in place of n cube, 1000 has taken the place. In place of 2 pi h cut, 2 pi h cut is equal to simply h, because h cut is equal to h over 2 pi. So 2 pi will be cancelled with that 2 pi, and hence in place of this only value of Planck's constant h is used. Okay, I think there is no further need of any further explanation. The remaining thing is just simplification. Okay, here dear students, electron volt into nanometer square will be cancelled with the electron volt into nanometer square. Moreover, this electron volt will be cancelled out with this electron volt, and our solution will become only in the form of unit second in the denominator, that is 1 over second or second raised to the power minus 1. And we know that 1 over second or second raised to the power minus 1 is equal to hertz. 1 hertz Hz is equal to 1 over second inverse. Okay, so after simplifying this, actually dear students, this 10 raised to the power minus 15 will be shifted to numerator, and it will become 10 raised to the power plus in the numerator. So nothing else, just simplification. Okay, and in simplification all units are cancelled. That is electron volt into nanometer whole square is cancelled with this electron volt into nanometer whole square. This electron volt is cancelled with this electron volt, and only 1 over second is left. 1 over second or second inverse, that is second in the numerator with power minus 1. And we know that 1 over second or second raised to the power minus 1 is equal to Hz, hertz. So all this in a simplified form becomes equal to this hertz, and further simplification gives this result 0.0066 into 10 raised to the power 15 hertz. And this simplification further gives rise to this. Okay, because what we have done, we have shifted decimal at here, and when we convert 0.0066 into 6.6, then this 10 raised to the power 15 will be reduced to 10 raised to the power 12 hertz. Okay, so one part is solved, and now we move to next part of part A, remaining portion of part A. Okay, we know that radiation frequency is given by this. What is this? This is tool number 2. We have not changed anything, quite same as was given in tool number 2. Okay, we have just reproduced tool number 2 here. Okay, in tool number 2 this is given and this is also given equal to this. Okay, so equation number 2 has been written exactly same as it is given in tool number 2, and tool number 2 is exactly same which is given in the book Modern Physics by Kenneth S. Crane. Okay, using n equal to 10 in equation number 2. In this equation, when we will use n equal to 10, we will get f equal to this. Okay, it will become 19 over 80 100. Okay, because when we will put n equal to 10, it will become 20. So 20 minus 1 19, and here 10 minus 1 9, and 9 square 81. Okay, but now here a question rises, in place of 81, why it is 8100? Okay, we yes, oh yes, clear. Actually this is n square. In place of n square we will get 100. Okay, because 10 square is 100 and 10 minus 1 square is 81. So 81 into 100 will become 8100. Okay, so things have become quite clear like a crystal. Okay, now dear students, here once again we will repeat our previous trend in which we have separated this combination of physical constants. Okay, because I am giving much importance to this combination of physical constants, that is E square over 4 pi epsilon naught, which has value equal to 1.440 electron volt nanometer or million electron volt femtometer. Okay, so here this factor is written as a square. Moreover, with m we have multiplied and divided it with the c square, and out of 64, 4 into 4 16 has been deducted, while remaining 4 was left, and that 4 is written here. Out of pi cube, pi square has been deducted and simply pi has been written here. Moreover, out of h cut cube, here h cut square has been deducted and it has been combined with this c square, which has been used as an arrangement. Okay, it is multiplied as well as divided by c square, and hence h cut c whole square. And because it is h cut cube, so in addition to this h cut c square, one h cut will still remain. Okay, and this will remain as exactly as it is already existing. Okay, now in place of this we have used this value in square, because this is in square. In place of this value we have used this value. Okay, moreover, in place of 4 pi we have not disturbed, it is still 4 pi, but in place of h cut c we have used its alternate value, which is 197 million electron volt femtometer square, because this is in square. Moreover, h cut, in place of h cut we have used this value, because we know that h cut or h bar or h reduced is equal to Planck's constant h divided by 2 pi. So this is the value of Planck's constant h, and it is divided by 2 pi. This 2 pi will definitely be cancelled with this, and here only 2 will be left, pi will be cancelled. Okay, so in next step just simplification, nothing else. Okay, here electron volt will be cancelled with electron volt. Okay, electron volt will be cancelled with electron volt. Yes, This is million electron volt into femtometer square, and this is also million electron volt into femtometer square. Okay, it is in the numerator and it is in the denominator. These two will also be cancelled. Okay, so same situation. This electron volt will be cancelled with this electron volt, and hence we will be left with the only unit second, and second will appear in the denominator, that is 1 over second, or second in the numerator with power minus 1, and we know that 1 over second or second in the numerator with power minus 1 is equal to hertz Hz. Okay, so its unit will be hertz, and after simplifying this factor becomes this. Further simplification gives this result, and further simplification gives this result. Okay, because when we will convert 0.0077 into 7.7, then this 10 to power 15 will be shifted to converted to 10 to power 12 hertz. Okay, this is solved. Okay, part A has been solved successfully. Not easy task. Alhamdulillah, Allah Almighty has given strength, power, persistency to solve part A. Only part A was difficult. Part B, C and D are very simple. Okay, because we have to make a very small arrangement. Okay, yes students, about part B, C and D we will use this methodology. We know that Fn is equal to this is expression, and F10 is equal to this we have found in previous part A. Okay, when F10 is equal to this, and we know that Fn is equal to n cube, so if we want to find out F100 in place of F10, then what we will do? While here in case of F10, here is 10 to power 3, that is 1000. 10 to power 3, it means we will multiply it with 1000 so that it will eliminate, and we will divide it by 100 raised to the power 3, that is 1 million. Okay, so the same thing we have applied here, that this value multiplied by 10 raised to the power 3 divided by 100 to power 3. Dear students, this is the main point. I have not copied this practice, this trend from any book or any. This is my own understanding about this. Okay, it is quite clear that when F10 is equal to this, and we know that in expression n cube is in the denominator, so in case of 10, this is 1000. So when we will multiply it with 1000, this n cube will disappear, and in place of this n we want to bring 100. So 100 cube will be used in the denominator. Okay, so that is why this. So after simplifying, it has become equal to 6.6 into 10 to power 9 hertz. What is the difference? Difference is that F10 was equal to 6.6 into 10 to power 12, while F100 has become equal to 6.6 into 10 to power 9. Okay, 12 has been reduced to 10 to power 9. We apply the same fashion, same pattern to part C, in which we need to find F1000. Okay, we repeat the same methodology here. Okay, we know that Fn is equal to this, F10 is equal to this. When F10 is equal to this, then F1000 will be equal to, we will multiply it with 10 to power 3, but we will divide it with 1000 power 3. And 1000 power 3 will become equal to 1 into 90. Okay, so this, out of these 9 zeros, these 3 zeros will be subtracted because these are in the numerator and these 9 are in the denominator. So here will remain 10 to 6 zeros will remain. Okay, so yes, these are 12 and these are 6, so it will reduce to 6. Okay, so what is the difference? F10 was equal to 6.6 into 10 to power 12 hertz, and F1000 has become equal to 10 to power 6. Okay, we have seen that F10 was equal to this, while F100 has become equal to 10. This has reduced to 10 to power 9, while in case of F1000 it has been reduced to 10 to power 6, and this trend will continue. And in part C, in place of 1000, we are going to find 10,000. When 10,000, we will use 10,000, then this value, which was originally 10 to power 12, then it became 10 to power 9, then it became 10 to power 6, then it will become 10 to power 3. Okay, so this trend will prevail. Let us see in part D. Okay, part D, Fn is equal to this, F10 is equal to this. When F10 is equal to this, F10,000 will become equal to, multiplied by 10 to power 3 divided by 10,000 to power 3. Okay, so these 4 zeros will be converted into 12 zeros. Out of these 12 zeros, 3 zeros will be subtracted and these will remain 9 zeros. So 9 zeros, this is 9 and this is 12, so 12 minus 9 is 3. Okay, so that is why 6.6 into 10 to power 3 hertz. Okay, so F10 was 6.6 into 10 raised to the power 12 hertz. F100 has become equal to 10 to power 9 hertz. F1000 has become equal to 10 to power 6 hertz, and F10,000 has become equal to 10 raised to the power 3. Okay, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.